In the previous video, we kind of talked about reaction rate, and we defined it as how fast a reaction proceeds. We looked at a nice little graph with the concentration of reactants and products, and we saw how the reaction rate changed with time. In this video, I'm going to be talking about 5 big factors that affect reaction rate. So the first one is nature of reactants. So what does that mean? What I mean by nature of reactants is, let's look at the reaction of magnesium with hydrochloric acid. That is going to yield magnesium chloride and hydrogen gas. And this magnesium chloride is in aqueous solution. Okay, so let's say for one reaction we used a big piece of magnesium, like a really big block, and we dumped that into the hydrochloric acid. And then in another reaction we took that big block and we split it up into little tiny pieces, and we also did the same thing. Which reaction would occur faster? Well, obviously when we use smaller pieces, it's going to react faster, because since they're smaller pieces, more of the hydrochloric acid, the hydrogen, the chloride, can react with this magnesium. Because it's a smaller piece, there's more surface area, and that's why that reaction will proceed faster than just dumping a big block. Also, a way you could experience, look at this, is that if you take a big block of salt, like a really big block, and you put that into water and let it sit, and if you took the salt and we crushed it into tiny pieces and we put that into water, obviously the tiny pieces will dissolve faster than that one big block. That's why for Kool-Aid, obviously if you ever want to like mix Kool-Aid and you want to make Kool-Aid and you have that powder, if you have any big chunks, you're going to want to crush that into powder, because if it's tinier pieces, then it's going to dissolve faster, and that's why the solution will be faster. So that's what I mean by nature of reactants. Also, one other important thing you probably should know is ionic substances tend to react faster than covalent substances. And why is that? It's because in the ionic substances, the electrons are already transferred between the ions. In covalent substances, the electrons are being shared. So that's why it's harder for the covalent substances to react. Okay, so that's the nature of reactants. Second is the concentration of reactants. We looked in the previous video about the decomposition of dinitrogen pentoxide. Let's look at another reaction. Hydrogen gas reacting with oxygen gas to form water. Okay, there's a reaction. So obviously, if you have a higher concentration, gases can have concentration, by the way. So if you have a higher concentration of hydrogen and oxygen, the reaction will proceed faster than if there were less, if the concentration was less of the hydrogen and the oxygen. And why is that? If you have higher concentration, that means you have more particles per unit area, so more collisions can occur between these particles. Later we'll talk about collision theory, but basically there's more particles per unit of volume, so that means there's more collisions. Since there's more collisions, the reaction rate will be faster. Okay, so you increase concentration of reactants, the reactions will go faster, and you decrease the concentration of the reactants, then the reaction will proceed slower. Okay, pressure, this is only for gases. Well, let me write the reaction again. So if we increase the pressure for this, if we increase the pressure, then all these gas particles are going to come closer together, right? Since the gas particles are going to come closer together, then there's going to be more collisions between the particles. More collisions means that more of the reactants will turn into products. So if you increase the pressure for a reaction that involves gases, the reaction rate will increase. The reaction will proceed faster. Okay. Temperature, same thing. For temperature, I think I've mentioned this quite a few times. Temperature is the average motion of the particles within a substance. So if you increase the temperature for reaction, then the particles will move a lot faster. If the particles move more faster, there's more collisions between the particles. If there's more collisions between the particles, then the reaction rate is faster. So increase the temperature, reaction rate gets faster. Decrease the temperature, then the reaction rate gets slower. And finally, catalysts. Catalysts, we talked about the activation energy for a reaction in the thermodynamics unit, I think. But For a catalyst will obviously make a reaction faster because the activation energy is going to be lower. It's going to decrease the activation energy for a reaction. So since the activation energy is decreased, the reaction there's more of the reactants can turn into the products. Okay, so if you have a catalyst, the reaction rate is faster as well. Okay, and then the two types of catalysts are heterogeneous catalysts and homogeneous catalysts. So heterogeneous catalysts are catalysts where like you have the catalyst and then the reactants come on top of it, and the catalyst makes it faster. So for example, in catalytic converters in cars, whenever the gas reacts in your car to turn into heat, so I don't know exactly how cars work, but the gas is going to react, the gasoline, sorry, and it's going to react and it's going to turn into these poisonous gases, and those gases can't be released to the environment. So that's why the catalytic converter has to take these poisonous gases and turn them into less harmful gases. And usually that happens on a some sort of catalyst here, right? This is the catalyst, this block right here. And then all these gas particles are going to become, and they're going to sit on these. So let's say we have two gas particles. They're going to come and they're going to sit on this catalyst, and then the catalyst is going to make it easier for these two gas particles to react and turn into product. So that's a heterogeneous catalyst. Okay, a homogeneous catalyst is a catalyst which is in the same phase as the reactants, and we'll touch back on that later when I talk about reaction mechanisms. But good to know 5 factors that affect reaction rate. If you ever need to explain on the AP test why like one reaction proceeds faster at some condition than another reaction, these 5 things will help you explain that. Factors that affect reaction rate, these 5, memorize them, they're pretty simple.